This begins part 2 of the description of the Argon triple point apparatus. You can see here we've got the 3 tubes I described in part 1. This one is the filling tube, this is the re-entrant tube where we put the thermometer, and this side is the pressure release valve. Now I was using this yesterday, so I've come in early this morning and it's just as I left it last night. So the first thing I do is to prepare to fill the apparatus with liquid nitrogen, for which I'm going to carefully remove the thermometer, undo the tube we use for filling. Now the funnel which we use to fill the apparatus has to clip and unclip, so this is a little device. It screws into the top instead of the cap and lets me push on the funnel. It might not be the final thing we use, but it's what we use now. So here's my funnel, but before I put that, I've got a second funnel which sits into the re-entrant tube. I want to cool the re-entrant tube preferentially. I want to cool it first. So I put both funnels on. This one is going to fill the whole container and this one is just going to fill the re-entrant tube. And first of all I'm going to fill this funnel to preferentially cool the re-entrant tube. You should be wearing gloves and zoot suits and hats, but if you're careful you don't need to. Now I note the time and it's just 2 minutes past 7. And I'm beginning the task of cooling. Now we're going to put liquid nitrogen in here, about 3 loads, keep this topped up for the next 15 minutes, and you can just keep an eye on the clock and we'll fade out and fade back in again at 1/4 past. We've flashed forward in time, as you can see from the clock there, and this container has been boiling away, cooling the re-entrant tube for about 15 minutes. What we also need to do is to allow an outlet for the nitrogen gas as it boils off, and we don't need the pressure release valve. So the pressure release valve dome comes off. These are the weights which set the boiling point temperature. It's very hard to do looking at the camera when you're trying to pick something up. So those are taken off and put somewhere safe. We don't need those until we actually seal the cell later. Put the dome back to stop condensation, and now I'm ready to begin not only filling the re-entrant tube but also filling the main container. Each time I empty a litre into here, I just make a note of it on my logbook so I know how much I had to put in to cool it down. Typically takes 22 litres on a Monday because we're cooling it down from room temperature. This morning when I came in, the temperature was minus 138 degrees Celsius, and so it's not going to take as many litres to cool it down, typically 12 or 14 litres. And that will take quite a long time, 1.5 to 2 hours, and all I'll be doing is just topping up both of these funnels. Right, welcome back. You can see from the time that we've elapsed nearly 2 hours. I've introduced 15 litres of liquid nitrogen into these two, and at some point the container becomes full. It can't come out anywhere else except around here, and if you look carefully you can see the liquid nitrogen actually trickling out through the pressure release valve. What we're going to do next is to remove the two funnels. They've done their job and filled the apparatus, and replace them, one by a seal, so that we seal the cylinder, and here where the re-entrant tube is, we're going to remove the funnel and we're going to put in our standard platinum thermometer, which we're going to calibrate. As you can see, we've now put on the cap where there used to be the filling tube, and that's sealed. The thermometer is now down at the bottom of the well, ready to be calibrated. And this is the pressure release valve, which is the only place where the nitrogen inside can boil off, and you can see coming out. The trouble is it condenses moisture, and so we use a hot air gun to warm the tube above its dew point, and so boil away any moisture that could grip the weights that I'm going to put on here. That done, we introduce the weight. This is a little cap that goes over to support the weights, and it's got a ball bearing inside it, which is the only contact with the pressure release valve tube. We then have calculated that we need 161 grams to take the boiling point of liquid nitrogen to a temperature just above the Argon triple point. So those are put on and everything's free to spin, and we now wait for the pressure to build up to a point where this will lift and you start to hear a hissing noise where the liquid nitrogen, having turned to gas, boils out. Comes out of one tube at the back of the pressure release valve and another tube here, which guides the gas around the re-entrant tube and so stops the standard platinum thermometer from freezing in due to condensation from the atmosphere. So we pop that back on. That stops again any condensation, and we wait. There's nothing else for us to do. There's no moving parts, no nothing. And what will happen is that the temperature, which is now in the re-entrant tube down near liquid nitrogen, will gradually increase until in the liquid it gets to a temperature just above the Argon triple point. But inside the re-entrant tube, because the argon is going to slowly melt, it goes on to a plateau which can last between 4 and 5 hours. And we'll show you some of the results from this actual run tomorrow.